Hello, I'm Matt Lally, MD, psychiatrist, founder of LallyMD.com. In addition to being a psychiatrist, I enjoy creating animation, and I have the website LallyMD.com that produces animated psychiatric apps. You can get these apps at LallyMD.com, or you can search the Apple App Store. These apps are used by thousands of healthcare professionals around the world. Today I'm happy to present my latest app, Cannabis and collegehealth.com. You can view this app online. Just type in Cannabis and College Health, one word.com. That's Cannabis and collegehealth.com, or visit LallyMD.com. This app can stand alone. You don't need to listen to my commentary. If you don't want to hear me discuss this app, just view it yourself on your mobile phone, tablet, or desktop. It's really intended to be a standalone app. You can also listen to this video for my commentary. Either way is fine with me. Let's get started. If you're looking at this app on your own, if you want to advance the animation, click this orange circle. It usually has an arrow in it. Sometimes there's a question mark, and that will advance the animation, so let's do that. Sometimes I give this webinar with the title, But Doc Weed Helps My Anxiety. Sometimes I use other titles as well. And again, if you want to see this, you can go to this website directly, or you can see my other apps at LallyMD.com. This is a scientific, evidence-based presentation. I want to emphasize that this is evidence-based. Sometimes I have my own commentary. I'll include that, but generally it is evidence-based, and all the references are included in this presentation. If you want to look at a reference, there will be a spinning asterisk in a pink circle. If you click that in your browser, it will open a new window that will have a link to the journal article that's cited. If you're on your organization's website, it's very likely that the entire original article will open, and you can view that directly on your browser, and the Cannabis and collegehealth.com will still be open on a window as well. We've covered this. If you want to jump back or rewind, just click that blue circle while the animation is running, and it's kind of a rewind button. A note to viewers, this is quite important. This is a mental health presentation. This is not an anti-cannabis presentation. I have nothing against cannabis. This is a subtle distinction, but I hope you'll understand. This is a presentation for clinicians who see patients struggling with anxiety and depression symptoms. I know I do. And also patients that use cannabis frequently. So that's what this is about. It's not an anti-cannabis presentation. I will admit that it may seem that way, and I encourage you to keep this in mind because it is a subtle distinction, but I think it's important, and I want to emphasize it, and I will emphasize it a few times as we go. As an example of this, or to illustrate this before we get started, I want to discuss briefly and then revisit later an article in the Journal of Affective Disorders in 2017. This study found that cannabis use was common in patients that they were studying who were seeking treatment for depression. The reference will be available. What they found is the patient using marijuana demonstrated significantly less improvement with regards to their depression and anxiety symptoms or symptomatology, as well as worse mental health functioning than those not using marijuana. And the authors want to emphasize the importance of screening for cannabis use. And they also note that patients with depression or anxiety might be motivated by knowing that in their study, those using cannabis had a worse treatment outcome. So that is the intended goal of this app and this presentation. And again, I want to emphasize that. I think clinicians that see patients will understand that. So let's get started. If a patient has a complaint of depression, anxiety, or ADHD, and the patient uses cannabis frequently, the patient should be supported to at least consider reducing cannabis use because, as we'll show, it's likely to improve their prognosis. And the evidence shows that cannabis use regularly can negatively impact mood, anxiety, and concentration. Now, as a word, not all studies show that cannabis worsens these features and these problems, but a lot of evidence does, and I will review some of that evidence. This animation app or presentation is going to empower you with the knowledge of cannabis in the brain. With the knowledge, your anxiety about addressing cannabis with your patients will be reduced. And once you address cannabis with a patient, they will now have the opportunity to consider making changes. It's their choice, and it's their choice if they want to make that change. The only situation we will discuss is when a patient regularly uses cannabis and presents with a mental health concern. Someone using cannabis infrequently is not really the focus of this presentation. Frequent cannabis use where a person doesn't have an active mental health concern is not the focus of this presentation. The patient, in my experience, will not come in and say they're concerned about their frequent cannabis use. They may come in and say they need something for anxiety, they need something for depression, they need something for purported or possible ADHD. Or they may say it's a combination. That's common as well. If you, as the professional, do not identify frequent cannabis use, there is a risk of misdiagnosis and ineffective treatment. Without regular cannabis being recognized, there can be inappropriate medications. The medications always carry some medication risks. And if the medications won't work, and often they won't, there's the risk of adding more medications. For the patient, this will mean lack of progress. For you, it will mean the case won't progress for you professionally. And for the clinic, it could mean the clinic becomes swamped and there are inadequate resources. However, if regular, frequent cannabis use is identified effectively and successfully, there can be a non-judgmental interview, there can be education, there can be aligning with the student's strengths and goals, and there can be support and consistency. Now, there can be attention to other true comorbidities. That's appropriate. But losing focus on cannabis, if it is regular, if it is frequent, is a clinical mistake. Of course, the goal is to have the patient return to the level of functioning, effective functioning that they seek. That's what they seek when they come into the clinic. That's what they seek when they come to sit down with you. They may not know the pathway going forward, but that's our job, and that's what we're here to help them with. So that's what we're going to focus on. Again, this is not an anti-cannabis animation or presentation or app. Cannabis is enjoyed by countless people and has been for thousands of years with no problem. The evidence shows that, and these are approximations, that 90% of people enjoy cannabis with no problem. 10% may have negative consequences. This is probably analogous to alcohol as well, the 90-10 split. We're even going to be discussing and focus on even a smaller subpopulation, those with negative consequences using regularly or frequently who are coming to the clinic with a chief complaint. So this is a small subset, but it's worth keeping in mind, and I hope that you will. Cannabis does have proven medical benefits. That's not the focus of this presentation. We'll review some of that as part of just understanding cannabis overall, and we'll review that, but it's not a pro-cannabis animation. I don't think anybody will think this is a pro-cannabis animation. And it's worth remembering that cannabis is not approved to treat any mental health condition. We'll talk more about that. Why discuss cannabis? This lecture, presentation, or app could be about other substances instead. The reason for this app or animation or presentation is for the following reasons. Cannabis is more common, likely more common than it has ever been. NIH states that more young adults report using cannabis on a daily basis than has ever been previously recorded. Also, there's the issue of the medical marijuana card for anxiety. There's no evidence that regular cannabis use helps anxiety. Of course, acute use, single use, infrequent use certainly can in the immediate short term, but regular chronic use, there's no evidence for that. So this can be confounding when a patient states they have a medical marijuana card for anxiety. In my experience talking with patients who have the situation, most often they'll share that the evaluation was brief at best, and there's also an article that reflects that likely possibility as well. Another trend is the legalization and mass public marketing of cannabis, at least in ever-growing number of states in the United States. The strategy for marketing seems to be, in my opinion, as someone who doesn't really know much about marketing, is to make cannabis use seem common, certainly beneficial and quote-unquote healthy and available, and this is, I assume, a common marketing strategy. Also, it seems to be at play currently with mobile phone sports betting, but that's my opinion. This is not my area of expertise. One consequence of these destigmatizing trends and also the increased use of cannabis is that patients will now present to the clinic using cannabis frequently and requesting and seeking and expecting you to provide mental health services. This is not a bad thing in and of itself. We want people coming in for treatment. We want people to share their distress. We want people to have appointments, and we want people to tell us about things in their life, including cannabis use. So this is not a bad thing as long as we know what we're doing and we know how to address it and we avoid misdiagnosis, which is a real risk. Frequent cannabis use can also be addressed in the outpatient setting. That's another reason and idea behind this app and presentation. Some substances are probably better addressed in a higher level of care than simply outpatient. But cannabis seems to be less addicting for most people. For many people, it's not addicting at all. For those that it is addicting, it's very likely that cannabis use in the outpatient setting can be an effective modality and treatment location. and for others, maybe a higher level of care is necessary and it is available. So let's get started. Again, we're talking about cannabis and mental health. There's going to be 4 chapters to this app and 4 chapters to this presentation. The first chapter is about knowing about cannabis use. I am not a cannabis user. Most of what I know, or everything I know, is from speaking with patients and also reviewing the literature. And in my experience, the more I know, the more it can make me confident and articulate with my patients. We'll talk more about that. It is hoped that this presentation, this app, will help you. Maybe you know enough, maybe you know enough already, but if you don't or you want to know more or refresh it, I hope this presentation will help you. I think some clinicians in substance use are cautious about asking about any substance use issue. It could be because the professional doesn't have any experience about it and they don't want to seem ignorant or less informed. Or maybe the professional has had some issues with it and doesn't want that to be known. Or also, we'll talk about other reasons as well, but lack of confidence can be a reason not to ask. Another reason people don't ask is they don't know what to do about it, or they're afraid it'll take too much time. It'll be like falling into a pit and they'll never get out of it as a professional. So we'll talk about the importance of asking and some strategies. The endocannabinoid system. I actually educate most of my patients who use cannabis frequently or regularly on the endocannabinoid system. And patients seem to appreciate knowing about it. The endocannabinoid system, the term, I find it awkward and certainly kind of off-putting. But despite the term, the concepts behind it I think are important. And I think they can empower you as a mental health professional if you don't know about it already. So we'll review that, and I think it's worth reviewing to understand cannabis. Lastly, there is no medical treatment for cannabis use disorder. Support, education, and consistency, that is the treatment. We'll be talking about that as well. So let's get started. We'll start with the first chapter, Know. Let's learn more about cannabis. If you don't know about it, or if you do, it's a review. Cannabis is believed to have evolved in Central Asia. It's now found throughout the world due to human activity, human behavior. There are possibly 2 other species, Cannabis indica, Cannabis ruralis, found in different locations. Some people think these all may be one species with different presentations, but I think from what I read, generally they're considered different species. Cannabis has been used by humans for thousands of years. I want to spend a little bit of time on other parts of the plant besides marijuana, besides THC, because there are other important parts of the plant, and I do think it's important for a good understanding. The first of the 2 I'm going to discuss is the fiber of the plant, which has been used and still is used for fabric, rope, paper, and clothing, referred to often as hemp. Actually, it was interesting to read that hemp has had a major historical significance. In the age of sailing, hundreds of years ago, hemp was necessary for national security. Countries needed hemp if they wanted to have ropes and sails for their ships in order to defend themselves and conduct trade. It was so important, it was considered a resource of national security, maybe analogous to the way that we consider oil or have considered oil. Hemp is still used. The seeds of the plant. The seeds of the plant have been used as a food. Other grains have become more popular, though in times of famine, people have eaten cannabis sativa seeds for nutrition. Even more recently, I was in a grocery store and I saw cannabis seeds for sale, and I hadn't seen that before, so they're still available as a food. The oil from the seeds is also used as an emulsifier in paints, makeup, etc. Now let's talk about the part of the plant that's going to be relevant to us as mental health professionals. That is the resin. The resin covers the plant, and that's where the psychoactive and medical properties of the plant come from. The resin contains over 100 different types of cannabinoids. The one we're going to focus on is THC, although there's only a relatively small amount of THC in the plant naturally. Let's cover a little bit of middle school botany. Botany is not an area of expertise for me. I had to read this to get some understanding. I hope it's helpful to you as well. In the cannabis sativa plant, where a branch connects with a stalk is called a node. At the node, the pre-flower grows. In the male plant, the pre-flower grows into a pollen sac. In the female plant, the pre-flower grows into the pistils. The pistil contains the stigma, the ovule, and the bracts. When the male plant matures, the pollen sacs rupture and release pollen that floats by wind to the female plant stigmas. Cannabis sativa plants do not have colorful flowers because they do not attract pollinators Wind is what they use to pollinate. They don't need colorful flowers. In the natural world, in the natural state, when the female plants are fertilized, their energy from photosynthesis is used to produce seeds. That makes sense. However, cannabis growers want that energy going towards the resin, which we briefly mentioned, not towards making seeds. They don't want the seeds. So the cannabis growers destroy all the male plants so there's no pollen and the female plants remain unfertilized, although occasionally a female plant can fertilize itself. Without the pollen, the female plant cannot grow seeds. That energy from photosynthesis goes to growing large buds. The buds consist of the stigmas, these orange hairs, the bracts, these green bulbs, and the sugar leaves. A large group of buds is called a cola. The bracts and sugar leaves are covered with small hairs called trichomes. Trichomes create the resin on the cannabis plant. They can be considered resin factories. The trichomes cover the whole plant except the roots. There are different types of trichomes. The female buds have the most trichomes. The resin from the trichomes contains over 100 different cannabinoids, over 80 different terpenes, and volatile sulfur compounds, which gives marijuana its skunk smell. Why does the cannabis plant make this resin? Nobody knows for sure. Scientists believe it likely relates to protection. Protection from the solar radiation of the sun, protection from insects and pests, protection from being eaten by animals. Is the protection related to people getting high from cannabis? Well, let me take a diversion and discuss the case of the Sonoran Desert toad. The Sonoran Desert toad lives in the Sonoran Desert, Arizona, Mexico, and maybe some other areas. There's a gland behind the eye of this toad that produces a chemical, 5-MeO-DMT. 5-MeO-DMT in the gland behind the toad's eye is presumably its protection against the many desert predators. For predators, this chemical is a neurotoxin. It's a deterrent. For some humans looking to get high from a hallucinogen or to have a hallucinogenic experience, the neurotoxin is neuroactive, but not neuroactive enough to make a person sick. It's only neuroactive enough to give them a hallucinogen, and that's what they're seeking. Believe it or not, they squeeze the gland behind the toad's eye, they lick it, they ingest 5-MeO-DMT. It is neuroactive, but not entirely neurotoxin, and it creates the hallucinogen that they seek. Now, does that relate to THC and cannabis? Let's talk more about that. There are reports of some animals becoming sick or dying from eating too much cannabis sativa plant. Yet it isn't clear that THC acts specifically as a neurotoxin protector or hallucinogen in the same way that 5-MeO-DMT protects the Sonoran Desert toad. The reason is, I mentioned earlier, there's actually, relatively speaking, little THC in the cannabis plant. Some of the other cannabinoids could be serving as a neurotoxin or protective, but not likely THC because there isn't very much of it. What is there more of? There's more of the THC precursor, THCA. THCA, which is more abundant in the natural plant, can be converted to THC if it's decarboxylated. The best way to do that is heat. Heat will decarboxylate THCA, turning into THC. Heating could be, for example, burning it for a joint or a bong, electric heating for vaping, baking it in the oven for edibles. Because THC does not occur in high concentrations in the cannabis plant, it seems unlikely that it evolved for the purpose of getting humans high. So why does it? Well, the greatest cannabis researcher of all time, Raphael Mechoulam, who sadly passed away earlier this year, he called it a quirk of nature, and I certainly don't have a better explanation. How do cannabis sellers or cannabis users access the THCA in order to turn it into THC? There's three methods. One is to dry it up and cut the buds, leaves, and stems. That's what's referred to as marijuana. Another method is to manually rub the trichomes off the buds. We talked about the trichomes. They can also be scraped off with an implement. That's sometimes referred to as hashish. A third method is to use a chemical solvent to extract THC concentrate, sometimes referred to as hash oil. It should be noted that some references discuss that it is possible that the chemical solvent itself, if still present, could present as a chemical risk to the user. You've probably heard that the potency of THC is increasing over time. It's just one of those urban myths that people use to, I don't know, scare people away from cannabis or something similar. Actually, according to several different resources, it seems to not be an urban myth. It seems to be true. There's a reference you can click here, and basically it summarizes, and different references have different amounts, but generally it seems to be, over the years, it seems to be that the concentration of THC is increasing. This makes some sense from a marketing standpoint of view. It's not surprising or unrealistic. Let's shift a little bit. Let's talk about the short-term effects of THC on the human body. You may have heard of these things before. Not all of this is relevant for us, but I think it's worth discussing for context and so that you can have the confidence when discussing THC with your patients. So let's review this now, and we'll come back to review it in some detail, but hopefully not too much detail. How does THC, one chemical, cause so many different reactions in the human body? Well, the answer to that is what we referred to earlier. I discussed the endocannabinoid system earlier. One of the most, or if not the most important part of the endocannabinoid receptor, probably not the most important, one of the most important is the endocannabinoid receptor. Again, I find the term endocannabinoid rather awkward, but there's nothing I can do. That is the term. The endocannabinoid receptor, like other receptors, is an extremely small receptor that is embedded on the surface of many cells in the body, allowing cells to communicate with one another. Like other receptors in the body, they consider that it works in a lock and key type method. You're probably familiar with this from other receptors and so forth. The endocannabinoid receptor was first discovered in 1988. It's present in mammals, fish, and birds. It's present in humans even before birth, and is one of the most common receptors of its type in the human body. So this is not a minor receptor. There are at least two different types of endocannabinoid receptors. Endocannabinoid receptor 1, which I'll abbreviate, is generally abbreviated as CB1, and endocannabinoid receptor 2, CB2. For CB1, it's mostly in the brain, though not entirely. It is the psychoactive, hold on, I made an error there. Let me advance forward. I've just hit the rewind button. I'm going to go forward and get us back to where we were because I advanced before I intended to. So this is, again, we're going forward looking at the endocannabinoid receptor. You can also hit the rewind button on the app if you want to use yourself, if you made the same mistake that I just made. So endocannabinoid receptor 1, I'll just go through this, is the mostly in the brain. It is the psychoactive receptor. It is responsible for reward, dependence, and tolerance, withdrawal of THC. We'll talk about those. CB2 is mostly outside the brain. THC will interact with the CB2 receptor, but it's non-psychoactive, and is possibly related to increased immunity and decreased inflammation, and it is being studied by scientists and pharmaceutical companies for those reasons. Now advancing properly. It's important to remember that the endocannabinoid receptor did not evolve to match up with cannabis. That doesn't make any sense. It evolved to communicate with other cells of the brain. We'll talk about that in a minute. It is possible that cannabis, as we discussed, may be similar to the toad. It's possible that cannabis itself evolved to fit, or at least there was evolutionary advantage to fit into the endocannabinoid receptors. That's hypothetical, but it seems not too far-fetched to me. It is a little bit misleading by the receptors. By calling it the endocannabinoid receptor, it sounds like it's meant for cannabis. That's not the case. That's just how scientists clarify which receptor they're talking about. That also happens for nicotinic receptors, opioid receptors, and other receptors. It's just part of the scientific nomenclature, but I find it a little confusing. What is the CB1 receptor intended for if it's not intended for cannabis sativa plant? Well, it's intended for the endocannabinoids. These are the natural keys that fit inside the lock that the brain releases from other cells in the body. The first one was discovered in 1992, anandamide. Another one, I just call it 2-AG. I suppose it's called arachidonyl glycerol. There are maybe others, and probably are other endocannabinoids. Anandamide, for example, increases with regular exercise and may be responsible for runner's high. Mice that ran on a wheel had more anandamide and less pain and anxiety than other mice. In experiments, monkeys will self-administer anandamide in a pattern similar to THC and cocaine, so it seems reinforcing. Click these asterisks for the, if that's how you say it, for the direct connection to these links. They're interesting articles. How important are the endocannabinoids? Well, I'll give you an example. There is a endocannabinoid receptor discovered by a pharmaceutical company called Ramonabant. We'll talk about more about that. It's an endocannabinoid receptor blocker. If that's given to a baby mouse, the mouse will not suckle and will die unless it is rescued. Rescued by THC or 2-AG. You can see the reference if you want to look at that article. In other words, I think it's fair to say that endocannabinoids are necessary for life. Let's review which keys go into the which quote-unquote keys go into the endocannabinoid receptor, quote-unquote lock. We talked about anandamide and 2-arachidonylglycerol, and the effects, we'll talk more about those. We talked a little bit about cannabis sativa, the plant, and THC. It should be noted, and we'll discuss more, that when someone uses cannabis, there is more THC around for longer than naturally occurring endocannabinoids. There'll be ramifications of that. Marinol is it's THC. It's THC in a pill form that's marketed for weight loss and HIV and nausea and vomiting and chemical. It's just THC. There are synthetic cannabinoids. You may have come across this in your clinical experience. A researcher at Cornell named John Huffman began to synthesize and design synthetic cannabinoids in the 1980s at Cornell. Eventually, these synthetic cannabinoids were discovered and then, quote-unquote, hijacked by entrepreneurs and sold as K2, Spice, and lots of other different names. I don't see these as much as I used to in the past, but I'm sure they still exist in the clinical sense, I mean. So we discussed the three types of keys that could fit into and do fit into the endocannabinoid receptor. Let's look, we said earlier that cannabis can cause these different types of effects in the bodies. Let's take a look at some of these. Not all of them are relevant for discussing mental health, but it might be important to know about that. One effect of activating the endocannabinoid receptor is decreased nausea and increased appetite. The rimonabant, the CB1 blocker we discussed in the past, was marketed in the past for a weight loss drug, and it is effective as a weight loss drug, but as you could expect by understanding the endocannabinoid system, it can increase depression and anxiety because it is blocking the endocannabinoid system. Pain, there's research into the endocannabinoid system and reducing pain, and there's evidence for that. Eye pressure, you've probably heard that cannabis can reduce the eye pressure of glaucoma. In my reading, there are better, generally medical treatments than cannabis for reducing pressure, though cannabis does do it. And there are the synthetic cannabinoid, nabilone is marketed in Europe for the treatment of glaucoma. So the endocannabinoid system, including THC, can reduce eye pressure. Muscle spasticity, endocannabinoids can reduce muscle spasticity, and that has medical ramifications. Let's discuss euphoria. Euphoria is the opposite of dysphoria, and I'll use them as opposite sides of the coin. Euphoria on one side, dysphoria on the other. I consider dysphoria to be a combination of depression, anxiety, or both. French psychiatrist Jacques-Joseph Moreau, from his book Hashish and Mental Illness, describes subjects' experience with cannabis, and this may be familiar to any cannabis user. Feelings of happiness, excitement, enhancement of sensation, irresistible impulses. These are the reasons that generally recreational cannabis users use cannabis. What causes this euphoria, and what can we say about euphoria? To understand euphoria, it's probably best to review some addiction theory, which you may already know. I'll start with this aspect. In 1953, two researchers at McGill University discovered that rats would repeatedly press a lever if it sent electricity to an electrode placed in certain areas of the brain. My understanding is this is not exactly what they were looking for. It was just a discovery that they made accidentally. Certain percent of the brains are thought to be involved in reinforcement of natural rewards. The rat will hit the lever till it is exhausted. This is called intracranial self-stimulation. Attending to a rewarding reinforcer only and ignoring the other priorities and obligations of life is a disturbance of salience. Salience could be considered the core fundamental problem of all addiction, independent of the substance or behavior. Later, scientists found that animals would hit a lever in the same intense pattern in order to receive injections of certain substances. It was interpreted that these substances caused euphoria, at least initially. These substances include, but not limited to, amphetamine, cocaine, nicotine, alcohol, benzodiazepines, opioids, caffeine, sucrose, and cannabis, also possibly certain behaviors. These substances are not equally reinforcing. Cannabis is likely less reinforcing than the others. Some of this you may have heard of in the past or be quite familiar with. The nucleus accumbens is part of the striatum of the brain. The nucleus accumbens is often described as the site of action for addicting substances. There is now evidence that other structures of the striatum are involved. My knowledge of neuroanatomy is quite limited, but in my general sense is that there's more to the brain than we yet understand, but these are reasonable approximations based on scientific evidence as I understand them. So as we mentioned a moment ago, these various substances have one commonality. They will all release dopamine in the striatum nucleus accumbens. It's very interesting to me that all of these substances are chemically different. In fact, they have many different chemical structures, and in many ways they have nothing really in common except this one unique feature that hundreds of thousands of other chemicals don't have in common. We group these things together naturally. I think anybody would, but it's worth reminding that they're very, very, very different. They only have one unique feature in common, generally. Scientists can study this in real time. When the rat hits the lever, the drug is released, and the drug is released, scientists can measure dopamine levels in real time. It's very compelling. However, over time, less dopamine is released. There's a typo there. And so the rat hits the lever more and more. This is the idea of compensating for the eventual decrease of dopamine, trying to compensate for that reduction of dopamine by hitting or doing a behavior more frequently. There's evidence that humans have this behavior as well, with this general principle. The increased level of dopamine initially followed by the decrease with the repeated exposure explains the euphoria can later turn to dysphoria of substance use. If you ever work in a rehab or substance use setting where patients are admitted for detox or for treatment, this dysphoria will be quite common on initial admission, not necessarily later, quite often not later. Is there evidence this phenomenon happens in humans? Yes, there is. You're probably familiar with it already. Regarding cannabis, specifically in 2015, there was a study that gave a radioactive tracer and a dose of THC to 20 subjects. The subjects were then placed in a PET scan to assess the release of dopamine, and they did release dopamine as a response to THC. This was compared to the same subjects getting a radio tracer and a placebo instead of THC at a later time. THC, they found, caused increased level of dopamine in the region of the nucleus accumbens stratum. So just exactly as what we've been talking about in animals and with other substances, this has been proven in a study in 2015. The amount of dopamine released by cannabis was less than amphetamine, alcohol, and tobacco, and this may relate to the possibility that cannabis is either non-addicting for folks or sometimes, or if it is addicting, it's generally less addicting. One important note, and this is going to be an important distinction we're going to talk about later. This study was about one-time exposure to cannabis. Things will change when we talk about regular chronic use of cannabis and dopamine release. That's also true for other substances as well. If a person continues to take THC avidly, they may become eventually dysphoric just as the rat did. That's not always the case, but it can happen. We'll talk about this more in the Educate chapter of the app. Let's spend a little time on anxiety because cannabis and anxiety is an important subject. Here is an interesting study involving 2 mice. This study does not involve THC. It does not involve cannabis. It's purely a study of what the endocannabinoid system does in its natural state. They looked at 2 mice. The top mouse is a normal mouse. It has its endocannabinoid receptor just as you and I have our endocannabinoid receptors. In the bottom mouse, they took away the gene that makes or produces the endocannabinoid receptor. So that mouse does not have any endocannabinoid receptors. It's a knockout mouse. The mice's hind paw is connected to a small power supply. I don't endorse studies of animals. I'm just reporting on this. A bell is also placed in the cage of the mice. The second step of the study is that the bell is rung and both mice receive a small, short electric shock. They will not be shocked again in this study. The bell stops, the shock stops. The mice's behavior eventually goes back to normal. In step 4, the bell is rung, but there is no shock. There's never a shock again. Both mice react as if they're in fear. They call it freeze mode because the bell is rung. Why? Because they're expecting the shock. That's what happened before. That's how I would react. And so far in the study, both mice are acting exactly the same. So far in the study, it doesn't matter if a mouse has its endocannabinoid receptor or does not. But step 5 is where things change. The bell continues to ring. There's never another shock. The normal mouse with its endocannabinoid receptor eventually acclimates to the bell. It's not going into freeze mode or fear mode. It's just acting normally. It now considers apparently the bell to be benign because the bell continues to ring. It acclimates to the bell. Not so, or perhaps more accurately to say less so, for the mouse that lacks an endocannabinoid receptor. As the bell rings, it continues more often to go into freeze mode. This is not an absolute in the study. It should be taken as relative differences. I've made it a little bit simplistic here to show the trends. So what does this show? It shows that the endocannabinoid system, it likely shows the endocannabinoid system is necessary for anxiety. It's necessary to acclimate to a fearful experience. It suggests to me, though the authors don't, I believe, identify this specifically, it strikes me as a clinician that this suggests why people with PTSD may initially get relief from cannabis. And if you speak with patients with PTSD that use cannabis, they may tell you this. It's not uncommon in my experience to hear this. So it explains the reason for that. However, we'll see later in a very good study of people with PTSD, when they use cannabis regularly, they do not improve, their symptoms get worse. So this is again the difference between short-term use and long-term use, which is a major feature of this presentation. Drug seeking, another aspect of endocannabinoids, or the endocannabinoid system. In experiments, mice that had been made addicted to various drugs reduced their drug-seeking behavior when given the endocannabinoid receptor blocker, rimonabant, that's the endocannabinoid receptor blocker, rimonabant, which we've discussed, implying that the endocannabinoid receptor could be involved in drug-seeking behavior. There's other evidence to this effect. As a side note regarding addiction theory, there are generally 3 things considered triggers for relapse: stress, past environment, and available samples. This is an important part of relapse prevention and effective treatment. I, in this presentation, sometimes interchange attention and cognition. Attention should be considered to be a subset of cognition. Attention is emphasized because patients requesting treatment for ADHD is increasing, in my opinion, at a very notable rate, so it's worth discussing attention. Studies of cognition after acute use of THC have mixed results. This is likely because human cognition is complex and cannabis affecting the brain is complex. There is one study indicating that attention is improved after a single use of cannabis. We're going to focus on what's going to be more important, which is attention and regular cannabis use. As I mentioned earlier, I'm not a cannabis user, so I don't have any personal experience of this. Sometimes patients will tell me that they'll use cannabis in order to attend to something specifically. The examples I most often hear are playing a musical instrument, to focus on that, and the most common one is playing a video game. Occasionally somebody will tell me that they use cannabis before going to the gym, to focus on the gym, although that's less common. So, now that we have reviewed some background knowledge of the cannabis sativa plant, THC itself, and the endocannabinoid system, and the endocannabinoid system on the body, we are now well prepared to meet with our patient and discuss cannabis with the patient going forward, and discuss in the next 3 chapters. I will conclude this video at this time, and I will start the next video in a moment.